Why are networks getting so complex? We've seen a shift in network topologies over the past few years. You have users working from coffee shops, working from branch offices, your applications. They may live in the cloud. You're using platforms like Zoom, Office 365. Maybe you still have some applications running in your data center. You have VPN tunnels, firewalls, SD-WAN appliances all over the place, and still security gaps show up. And then you have a salesperson come along and say, you need SASE. Well, what is SASE? And do you actually need it? My name is Ryan Ashcraft, and I'm a senior systems engineer working with America's largest service providers to help them develop managed security and networking products for their end users. Traditional networks were built for a world where everything lived inside your perimeter. The bulk of your users were sitting inside branch offices. You only had a few remote users, and they just needed simple access to a file share. Your branch offices then connected into your data center where all of your applications were hosted. And then your data center had a centralized egress point where you had a firewall that just did basic inspection for your web traffic. You used high-cost MPLS links to connect everything together. And then technologies like SD-WAN came along, and you were able to replace these high-cost MPLS links with internet-based transport. But that opened up a whole new can of worms, because now you could split tunnel traffic out and connect to applications directly, but it was left unsecured. So you continued to send traffic back through your data center. This added latency. Your security gaps go up, your performance goes down, you're dealing with an influx of tickets from users wanting to know why traffic is slow, why they're having issues accessing certain applications. In today's world, users are connecting from anywhere. Applications live everywhere. You have dozens of disparate security solutions attempting to protect everything. So let's take a minute to talk about what SASE actually is. SASE, or Secure Access Service Edge, is a term that was coined by Gartner for the convergence of networking and security into a single cloud-delivered platform. So instead of sending traffic through your data center and back through firewalls, you typically would have a fabric of SASE points of presence, or POPs, that would be deployed as part of this platform. All users connect into the nearest point of presence using either a VPN technology or SD-WAN tunnel, delivering the best user experience possible. And then you would have unified security policy enforced at these SASE POPs. All right, so high level, what makes up a SASE platform? You have Secure Web Gateway, Firewall as a Service, CASB, ZTNA, and SD-WAN. You may see the term SSE thrown around as well. SSE is different than SASE. So Secure Services Edge, you notice it's missing the A for access. SD-WAN is our access portion. It's what provides us the network access to the platform. So when you look at platforms like Zscaler and you're connecting into Zscaler using a GRE tunnel or an IPsec tunnel, that would be a traditional SSE deployment. And then when you look at full-blown SASE, that would be like a Versa network, Cicado networks, where you would have integrated SD-WAN for your branch offices to then connect into your SASE fabric. Here's what happens behind the scenes. It all starts with ZTNA. Zero Trust Network Access is typically a client-based solution that is used to do an identity and device posture check before allowing our users to connect into our network. So different than legacy VPN solutions where we just authenticate a user and we say, okay, you now have access. We want to determine who is the user, what group do they belong to, what device are they connecting from? Is it a corporate device or is it a bring your own device? Is that device within our MDM compliance policy? Meaning, does it have specific sanctioned applications installed? Are those applications running? Does it have third-party applications which we do not allow installed? Are they connecting from an approved geographic region? And we take all of these data points in and we provide conditional access. So if you meet all of our criteria, you would basically be given access to all of the applications you need to perform your job. However, if you're connecting from your iPhone or your iPad, we may want to provide restricted access. We don't want to block you completely. We still want to let you log in and punch your time card, but we don't want to deny you completely from your iPhone. So that's where ZTNA comes into play, and it's all about determining who the user is, where they're connecting from, what they're connecting from, what do they need access to complete their job, and only providing access to those critical functions and nothing else within our network. Once we have determined all of those criteria, and we've decided to let this user have access, well, then we look at where are they coming from. If they're coming from a branch office, we can utilize SD-WAN into the SASE fabric. So we could use things like packet replication, traffic steering, forward error correction, app prioritization, all the way up to the SASE gateway and make the most of our bandwidth there at the branch office. If they're connecting remotely, we basically tunnel them in, either using SSL-based tunnel or TLS-based tunnel. It could be an IPsec tunnel. We could be doing like application reverse proxy. All of that is configurable based on the vendor that you go forward with. But the idea is that we want to take the best available path to bring the user into our SASE fabric. All right, now what happens? Well, once we're in the SASE fabric, that's where Secure Web Gateway and Firewall as a Service, CASB, come into play. We want to enforce consistent security policy regardless of if this user is connecting from Starbucks, from our branch office in Dallas, or from their home in Wisconsin. We apply URL filtering. We use things like data leak prevention or data loss prevention to prevent sensitive data from being shared externally from our network. We use CASB to limit what a user can do within SaaS applications. We don't own the application anymore, but we want to prevent certain users from being able to download or delete data from our OneDrive. That's where CASB comes into play. This all gets enforced within our SASE POPs, and it's a consistent user experience regardless of where the user is coming from. If we take a look at the ops side, it's a single policy, single dashboard. Our ops team creates these policies. They click commit, and this propagates across the entire SASE fabric. Now comes the big question. Do you need SASE? If you have a highly distributed workforce, if you are heavily reliant on SaaS applications, maybe you have dozens of security tools and you're looking to consolidate, in that case, yeah, I think SASE would be a good fit for you. Are you mostly hosted in-house? All of your applications still live in the data center? Do you have everybody working in the branch office? You only have a handful of users? Are you not facing, tool fatigue across multiple disparate products? Well, in that case, SASE may not be the right choice for you at this point in time. SASE isn't a product you buy. It's an architecture that you work towards. The goal is simple. You want to give users secure, fast access to applications from anywhere, and you want it to be easy to manage for your operations team. If you found this breakdown helpful, hit like, subscribe, and drop a comment below telling me where your organization is in your SASE journey.